Hey everyone, and welcome back to Chapter 13 of Cognitive Psychology, Psych 4100. This chapter is on judgment, decisions, and reasoning. It's also sort of represents, in a way, a much higher order level of cognitive psychology than we've been talking about all semester. We started our discussion about the brain and sensation and perception and attention and memory, these very, what you might call foundational or fundamental areas of cognitive psychology. And we've sort of built all the way up to this chapter where we're now investigating the way that people make decisions in the real world. So if we can imagine cognitive psychology as like a pyramid, the things at the bottom and the middle of the triangle or of the pyramid, the sort of foundation, the base, are these low level processes like attention, sensation, perception, and memory. That's kind of the mechanics of cognitive psychology. And then in these last couple chapters, including chapter 11, language, in addition to this one, we're sort of approaching the top of the pyramid, right? The sort of the pinnacle of cognitive psychology, which is what do we know about the way that people make decisions? So some questions that we want to consider for this chapter. What kinds of reasoning traps do people get into when making judgments? It might not surprise you that pretty consistently people make judgments that are inaccurate for some actually really understandable reasons. We can study the sort of consistent errors that people make in judgments. What is the evidence that people sometimes make decisions that are not in their best interest? This is not going to surprise you either, that people do not always make a decision that has the most utility, the most use for them. How do emotions influence decision making? And the idea that there are sort of two quote unquote ways of thinking. There's a very quick way of thinking, a very automatic, first blush way of thinking, and then there's a much more slow, measured manner of thinking. Okay, so let's get some definitions out of the way. Judgments are evaluations of evidence. So a judgment is an evaluation of evidence. Take this example. I performed poorly on my last exam. Right? That's an evaluation of evidence. The evidence is your score, right? The score that you received on the exam. Let's say you got a 65, and so you make a judgment, which is an evaluation of that data, and your evaluation of a 65 is that you did poorly. Notice that someone else could judge a 65 as being good performance. Imagine if you gave that exam to, your younger sibling who's in 8th grade and they've never taken cognitive psychology. They're not even in high school yet. You give them this exam and they get a 65. You'd say, damn, that's pretty good, right? Your judgment of the same performance would change based on the context, the situation. Reasoning is the process of drawing conclusions from that judgment and evidence. So let's continue with the same example. You got a 65 on the exam, so you make a judgment. I performed poorly on the exam. And so you draw a conclusion. I probably didn't study enough. Notice how this information, I probably didn't study enough, is you moving beyond the data. Right? The data are a 65. Your rationale, your reasoning for why that occurred is you trying to make sense of that data. Well, I reasoned that I probably didn't study enough. That's why I got a 65. So whether or not you studied enough is not included in the data, right? The 65 is a 65. but you take the step of reasoning about that data. You move beyond what is physically in front of you. And lastly, these judgments and this reasoning might force you to make a decision, right? Which is making a choice about your alternatives. So for the next exam, I will study more. I'm going to make a choice and a decision to change my behavior based upon my judgment and reasoning. Now, there are different types of reasoning that we can talk about. The first one is called inductive reasoning. Inductive reasoning is based on observations where we start with specific information and then we draw broader conclusions. So we start with specifics and we draw broad conclusions. You can think about this essentially as the scientific process, right? We gather evidence, we gather individual data points, and then we try to draw a larger conclusion from them. This is very similar to our example here from the last slide. We start with data, and then we draw large conclusions. Inductive reasoning leads to conclusions that are probably true. They are not necessarily true, but they are probably true. This is also the way that science works. And the strength of this reasoning is all about the data. How representative are these observations of the population at large? How many observations have you made? And how of what quality are these observations? Because if you draw conclusions based on bad data, then your conclusions will be bad. But if you draw conclusions based on good data, then we consider those conclusions to be stronger. So here's an example of inductive reasoning. All the crows I've seen in Pittsburgh are totally black. When I visited my brother in Washington, D.C., the crows I saw there were black too. Those are my observations. I observed black crows in Pittsburgh. I also observed black crows in Washington, D.C. I have a couple data points. I then draw a conclusion from those data points. All crows are black. Here's a second example. Ever since I can remember, the sun has risen every morning here in Tucson. I am going to conclude then that the sun will rise in Tucson tomorrow. So these are both examples of inductive reasoning. We're moving from discrete data points to larger, broad conclusions. But also notice that the first example about crows is probably considered weaker than the second example. So every day you observe the sun rising. That is probably thousands and thousands and thousands of data points. Also, the sun rising is really obvious. Other people can observe it too. We know other things about the sun. And so you're probably pretty safe in your conclusion that the sun is going to rise tomorrow in Tucson. That represents good data, good evidence, a high number of observations, high quality observations. So we're very confident in this conclusion. Versus the first example, where, okay, we saw some crows in Pittsburgh, they're all black. We saw some crows in DC, they're all black. But we haven't seen crows anywhere else. And furthermore, there's no way that we saw all the crows in Pittsburgh, and there's no way that we saw all the crows in DC. So while our conclusion that all crows are black logically follows from our observations, right? This conclusion is logical given our observations, it is very possible that this conclusion is not technically correct. It would not be surprising to go somewhere else in the world and find a non-black crow. That is certainly plausible. So just because a conclusion logically follows from the data does not mean we can claim that conclusion is the sort of capital T truth in inductive reasoning. But this process is the way we do science. Science is the sort of iterative process of building and building and building collections of these observations and conclusions. We base our current ideas and observations on the observations and ideas from the past. The idea being that over time, we slowly approximate the truth. So science does not make incontrovertible claims of the capital T truth. Science actually makes inductive reasoning probabilistic claims about what is most likely to be true. That is actually the way that science works. And of course, you use this type of reasoning in your everyday life as well. It's not just scientific reasoning. So let's say that last week your mom told you to clean up the kitchen and you didn't do it. And so your mom got mad at you. Right? Last week, when I didn't clean the kitchen, my mom got mad. She will probably get mad again this week if I don't clean the kitchen. So I should clean the kitchen. Right? That would be a conclusion, right? A rational decision that you could make from this inductive reasoning. So that's how much of our reasoning occurs in day-to-day life, inductive reasoning. We look at the world around us. We gather data points, whether you're doing that scientifically or unscientifically, right? Going about your day and the interactions you have with the world is you gathering data about the world, and then you use that data to form conclusions from your inductive reasoning. And so what people do to make this easier, because it's difficult to constantly be worrying about the state of data in the world about every little decision that you make, what people do is that they use some rules of thumb. We call these heuristics. People use heuristics to make their decisions easier. The problem is heuristics can often be wrong. So we're going to take a look at a few commonly used heuristics: the availability heuristic, illusory correlation, the representativeness heuristic, and the conjunction rule. So these heuristics are ways of thinking that feel like they make sense, right? They feel okay, but they often are not.